Hello guys. Today we have a laptop, a Sony. It's not turning on. Obviously there is no battery because I removed the battery. Let's connect the charger and then press the power button. As you can see, there is no light. So what you do, take your meter, you put it into DC voltage mode, and you check your charger. We do have 19 volts. This means the issue is the laptop. Okay, we have the board and okay, so what we need to do, it's simple. We need to check the 19 volts after the DC in. You take your multimeter, you put it onto onto DC mode, 20 volts. Start on the fuse. Do we have 19? We do have 19 on the fuse. What about the first and the second MOSFET? We have to look for the first and the second MOSFET. You look for something like this. Okay, DC in MOSFET. After a DC in jack, you will have the first MOSFET, something that looks exactly the same or look alike. Okay, after a charger, after a DC in jack, you look for that. It's called the first and the second MOSFET. It's called the MOSFET. Okay, you have to look for the MOSFET, and then after that you check for the 20 volt. Check for the 20 volt on the current sensor. The thing on number 3, that's a current sensor. You should have the 20 volts there. If you are getting 0 volts or less than 20 volts, let's say maybe 5 volts, it means you have to trace it back. The issue, it's on the board, on the first and the second MOSFET. If you don't have any power on the first MOSFET, obvious, you need to trace it back. You need to check your charger or check the DC in jack or the port itself, whether why. But in this case, we do have the 19 volts on the fuse. You saw, right? So it means our 20 volts is getting in, but now the output on those MOSFET we have to check. There we go. I don't know, but this is the MOSFET. I don't know where's the first one. Okay, so what you do, check for a short here. Put your meter into continuity mode. One probe to ground, and there is no short. Alright guys, so this is the input. Here we should have the 19 volts and then have the 19 volts here. After here, it goes on the other side of the board into a second MOSFET. This is tricky, but it's easy. So what we do, we connect the charger. Have to flip the port. So we're gonna check here on the input, see how many volts we have, and then check here on the output and see how many volts do we have. Let's go ahead. $19. What about the output? 19 volts. Okay, let's check the current sensor. It's easy that way. Okay, on the current sensor we have zero voltages, but here on the output of the first MOSFET we do have the 19 volts. So it means we're losing power on the second MOSFET. There we go. And that's a P channel MOSFET as usual, as I was expecting. How many volts do we have? We do have the 19. What about the output? The output we have 0 volts. Okay, what do we know about a P channel MOSFET? Okay, a P channel MOSFET should have a low voltage on the gate in order to allow that 19 to turn on, to pass by and jump into the other side. Let me repeat again. On a P channel MOSFET, the voltage on the gate should be lower than the voltage on the source. The voltage on the source, it's 19 volts exactly. It's 19.0 exactly. So the voltage on the gate should be lower, should be 15 volts, 16 volts, 17 volts, but it should be lower. There we have a problem. It's exactly the same as the voltage on the thing, and in this case it won't allow power to pass by because the voltage on the gate is exactly the same as the voltage on the source. I'm not sure if someone can hear me, but let me show on the camera. Okay. Oh, my camera is busy focusing on the scope. Yeah, there we go. Right, we are no longer focusing on the scope. I'm saying just check the voltage on the source. It's 19.05, and the voltage on the gate is 19.05. The power won't pass in this case. Should never pass in this case. It's either the MOSFET is faulty or the resistors are responsible for lowering down the power to 15 volts or 17 volts are faulty, or otherwise there's a problem somewhere. Let's see. Which one do we check first? Do we change that P channel MOSFET? Do we change it? Okay, guys, we changed the MOSFET, but still the short was there. Where's my? But still, the MOSFET didn't allow power to pass the second MOSFET. It's either the charging chip is faulty or there's a short on the board. So the best way, let's inject the 19 volts on this board, then we'll see if there's a short or not. So where do we inject the 19 volts? On this white thing on the current sensor, we need to inject the 20 point something Okay, so what you do here, stretch the board.
So let's.
All right, let's go ahead. Let's see what is taking the power. Yeah, boy, there's a short, and the power supply have been limited. Okay, you know what? There's a short on the spot. You know what? Let me do this. It's possible that the short is coming from the CPU, judging by the behavior of the first and the second MOSFET. So I'm just gonna remove the CPU, and again we'll be on the safe side as well. Oh, there's a short, lovely. Okay, you know what? Let's check for, because I did check for short on the current center, but there was no short, which means this is an active short. So what I'm gonna do, let's check the thing, and there's no short. Okay, guys, regarding an active short, it means it's only active when the power is connected, meaning the short is only active when the power is connected. Without any power, there is no short. So I've dealt with an active short. Okay, now it's checking one. Okay, I shouldn't be dumb. Let me remove the glove. Fuck! Damn it! Fuck! You! This is called a fuck method. Louis Rossman called this an owl method. Louis Rossman ubiza nge-owl method lempahla le actually shortcut nje yabo kusandla nje uthi owl method. Njalo method uthi ow. Mekho ayifake. Guys, this is hot. I call this a fuck method. Ha 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 ha. Finding a short using a fuck method is bad. Damn, and it's extremely hot, Baba. Yeah, she's a pay. And we are so good with this. I used to find a short by just looking at the thing capacity. We are so good. I don't know why I stopped using that method. You remember? Okay, guys, let's put the thing and then see. Damn. Check. This guy here. Yo. Getting extremely hot. Yo. Boiling. Yo. I'm gonna overcharge this client for bending my finger like this. Guys, this was hard, level hard. You know why? Because the short was not active. Was not an active short. It was only active when you connect the power. We had an active short. And active shorts are not easy. That's easy. I wonder where's the power button. Yeah, bro, on the current sensor, we do have 20 volts now. The power is passing through. Da 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 da. There we go. The fan is spinning. Do we have a display? Fan is spinning. Do we have a display? Yebo, operating system not found.